General theory of relativity and quantum mechanics are two pillars and foundations of modern physics. In this video, I am going to answer certain important areas while learning general relativity and quantum mechanics. What are the mathematical prerequisites that you have? What are the problems that you might face while learning general relativity and quantum mechanics? Which one you should learn first in order to gain a mathematical or a maturity in terms of knowledge of physics? Which one most importantly has got a greater career when you learn those and move ahead in your future career? What are the do's and don'ts? What are the available resources in learning these two subjects? Well, I am not here to give a comparison, but rather to give you a very unbiased opinion about most of the commonly questions asked regarding these two things, GR and quantum mechanics. In this video, I am going to give you a very detailed understanding and unbiased understanding which one you should go and what are the things, what are the resources and what are the areas of opportunity that lay ahead when you move ahead into research or in scientific career or you move out in a job. So I am not considering this to be a comparison, but rather a very unbiased opinion on the do's, don'ts, learning resources, whatever available in GR and quantum mechanics. My name is Shaunak and you're watching this video on my channel Physics for Students. A warm welcome to this fresh new video on something different, general relativity and quantum mechanics. First, I would like to talk about general theory of relativity. Now, those who already know me, those who are subscribers and those who are listening for the first time to my channel regarding this video, I would like to tell you that in my playlist and in my future or the old videos of general relativity, you have seen that I have always tried to give a very intuitive as well as a mathematical approach in terms of understanding general relativity so that most of the people in general, they can understand. Now you see, I have recently launched a video which talks about how to learn general relativity. So first point number one, which I would like to mention, that the problem that you face in understanding general relativity is that you make a big mistake by jumping directly into the mathematics of differential equations, curvature tensors, tensor calculus, etc. But just to tell you, first of all, general theory of relativity is more about what I call the geometry of space-time. That means obviously geometry consists of mathematics, but first of all you need to understand it is more about the geometry rather than mathematics. So the first thing that you should understand, that when you are studying general relativity or you are willing to study general relativity, what you have to keep in mind that you have to learn the geometry first. Now, what are the geometries, etc. I will explain in the next video, but this is basically the geometry, the non-Euclidean geometry. Primarily, I can call it as differential geometry. So, the basic problem that you face while studying general relativity is that you go directly into the mathematics without understanding what is the geometry, because relativity, special relativity is more about mathematics. General relativity starts with curvature of space-time, starts with hyperbolic and non-Euclidean geometry. So this is something which you must understand, that this is basically regarding geometry. Geometry results into gravity, curvature, geodesics, etc. So the first thing is that you should have a clear and a very good understanding of what is called the geometry or an overall idea of what is geometry all about, basically from Euclidean to non-Euclidean. Number one. Second thing is that when we talk about geometry, for example, school level geometry, say for example Euclidean geometry, parallelepiped, cylinders or three-dimensional objects, what you need to have in your mind is what is called an intuitive approach or a mathematical visualization. Now, when I talk of mathematical visualization, I mean to say, for example, there is a cylinder. If you cut the cylinder vertically, how it would look, what is the other face of the cube, all those things. That means in general relativity, otherwise, you need to have a very good understanding of what is called geometry or an intuitive understanding of the structures of geometry. So the first problem is that, because I always tell that general theory of relativity is basically more about geometry, less about mathematics. So it is more about intuition rather than your mathematical skills. Now, I am not saying that general relativity does not require mathematics, but it requires mathematics up to the, I would say, up to the level of geometry or a geometrical mathematics. It is mathematics obviously, but you need to understand geometry first. So first, number one is that if you have a very good understanding of geometry as a whole, if you understand what are curvatures, surfaces, 3-dimension, and you can just close your eyes and you can visualize things, then course or the right, I would say, subject for you to go ahead. Point number two is that general theory of relativity, remember, it is basically classical theory. That means I just started with part one, but I will show you in the later videos that it deals or starts with Newtonian gravity. It starts with Kepler's law. It starts with mass of a body, how the gravitating bodies are moving around a particular big mass, etc. And I have shown earlier in my videos also that from Newtonian mechanics, under very low conditions, when there is less gravitating body and the charges of black holes etc. are less, you can move into Einstein's field equation, and from Einstein's field equation again you can come back to general relativity. What does that mean? That either way you can go from classical to general relativity and from general relativity to classical. So second thing you need to keep in your mind is that you have to learn the classical mechanics very well. You cannot just skip that, okay, I am now into modern physics, I won't learn, or I can skip the certain concepts about, I would say, Newtonian mechanics. I'm sorry to tell, this cannot be done. You need to have a complete mastery of Newtonian mechanics, especially about gravity. So try to learn everything about gravity, everything about Newtonian mechanics, momentum, torque, etc. and then only you can go to general relativity. So the classical part, unless it is very clear from your side, you cannot move into general relativity. So you have to have a very good understanding of classical mechanics, especially gravity, on the laws of Newtonian mechanics. Okay, now I will come to about quantum mechanics. Comparatively, if I take a comparison between general relativity and quantum mechanics, I would say quantum mechanics is relatively easy than GR. Again, don't take me wrong. I'm saying that QM is relatively easy than GR. The reason why it is the reason is that quantum mechanics is more mathematical compared to general relativity. General relativity, for example, this is my hand and this is curved in a manifold, so you can see there are a lot of surfaces, etc. So what is the intrinsic geometry of the manifold? What is the extrinsic geometry of the manifold? So you really have to have that kind of an intuitive understanding. No mathematics can help you to have that kind of an intuition. Yes, intuition can be built in, critical thinking can be nurtured, but this is something inherent. You need to have a very good understanding about the curvature and intuitive understanding of geometry. And that is why the reason you will see 80 to 85% of the normal graduate people who pass out from colleges, etc., they go for quantum mechanics. As far as India is concerned, quantum mechanics, I have seen many in US who are going for GR. But anyway, as far as the things are concerned, you need to understand that quantum mechanics is relatively easy because it is more mathematical. You know probability, you know wave mechanics, you know partial differential equations, you know complex numbers, you know linear algebra, you understand what is a Hermitian matrix. You can understand quantum mechanics very well. But whatever mathematics you know very well, if you do not have an intuitive sense, then you cannot get hold of GR. This is one. Now, second problem with quantum mechanics is also this. It is very much counterintuitive. That means, how can a particle or an electron take both the ups and the down spin? That means quantum superposition. How can a change in this particle instantaneously causes a change in the other particles? Quantum entanglement. So things like which are counterintuitive, probability distribution, Fourier transform, these are quite counterintuitive. Counterintuitive means, I mean to say, in general, what common sense thinks, quantum mechanics is not the common sense. On the other hand, general relativity is more dependent on common sense, intuition. So if you have a very good strong background of mathematics as a whole, you can very well go deep into quantum mechanics. I will tell you what are the career opportunities also into that. And if you do have a very good understanding of the intuitive understanding of geometry, you should go into GR. So which one? I would say mathematically, classical mechanics. because quantum mechanics is something very counterintuitive. So the Bohr's atomic model or Rutherford's model or the general behavior of electrons and protons, they do not obey the I would say the possible laws or postulates of quantum mechanics. That means even if you say, for example, even if you don't understand classical atomic structures or classical quantum mechanics, there is nothing called classical quantum mechanics. Anyway, the atomic structure classically, even then you can do well in quantum mechanics. Why? Because quantum mechanics is modern, it is counterintuitive, and it does not rely too much on the classical structure of atomic models. But on the other hand, general relativity totally depends upon the classical structure of Newtonian mechanics, acceleration, gravity, and these things. So the mathematics, if you really understand mathematics well, quantum mechanics is the best thing for you. Okay, now coming up about the mathematics of quantum mechanics, you need to have a basic understanding of linear algebra, probability, wave mechanics, etc. Then you can do into the mathematics of quantum mechanics. Considering the mathematics of general relativity, oh my goodness, there are a lot of new things which you need to learn. For example, tensor calculus, for example, the entire branch of differential geometry, because this is a totally new area of totally new area of geometry. So you need to have a very good understanding of geometry, new modern non-Euclidean geometry, hyperbolic geometry, differential geometry, Riemannian surfaces, curvature tensor, Riemannian metric tensor, and the list goes on. Considering general relativity, the mathematics of quantum mechanics is much less. You don't have to learn a totally new area of geometry. Except the basic mathematics, you can do very well quantum mechanics. Okay, now I would come to the career opportunities of GR and quantum mechanics. Well, don't take me wrong, but I'm giving you a very unbiased understanding. Now, the career opportunities, if I talk of India, then the career opportunities in quantum mechanics is much more. Now, you might say why? The basic reason is that quantum mechanics is applicable to a huge arena of practical field applications of industry. For example, cryptocurrency. For example, digital securing of data, SSL encryption, quantum computing, deep learning, tensor analysis, tensor flow, all those things. I mean to say, a lot of things are there in quantum mechanics. Quantum mechanics, quantum mechanics also secures data. You will see very recently quantum, what you call the pen drives are using something which is called quantum tunneling. That means simple pen drives which we use in our daily laptops or other ways, they are using quantum mechanics. Transistors are now being replaced with the new technology of quantum mechanics. Quantum computer is coming up. Qubits will be used in different kinds of things. So there is a huge amount of scope of quantum mechanics, quantum computing, and a lot of other things. You can use the superposition and entanglement in order to make data security. You can use cryptocurrency. You can use the securing data, that is what is called cyber security. So there is an endless amount of opportunities in terms of quantum mechanics. Coming to general relativity, the opportunities are very, very less. Except research, except astrophysics, except astronomy, or in case that you are really going into theoretical physics, which has got less amount of practical application but more amount of a mental satisfaction, there you can understand general theory of relativity. There the general relativity actually comes into the picture. So you see, if I talk of IISER and Bangalore and other areas of India, you will see most of the applications are that of either probability as a whole, market research, market forecasting, future forecasting, probability theory as a whole, and quantum mechanics. General relativity, again, if you go into astronomy, then you have to find out an observatory where things will be there. You will be able to find out a very expensive telescope, black holes, prediction, models, etc. So I mean to say the chances of quantum mechanics are more in concern with general relativity. As far as India is concerned, if you want to go into pure theoretical research, pure astronomy, pure astrophysics, great. You can go into general relativity. Okay. I would also like to come to one very important thing which I generally face sometimes while making videos or doing my own researches, talking with my professors. If I say, for example, you're stuck in a problem. For example, you're stuck in a problem of quantum mechanics. It can be any kind of a problem. And I am stuck in a problem, say for example, deducing Christoffel symbols or any kind of a difficult problem of Riemann curvature tensors or parallel transport or covariant derivatives, say for example. If you go to internet or use Google Bard or ChatGPT or AI, you go to colleges, founder libraries, talk to the professors, you will see the amount of resource of general relativity is very, very less. I really don't remember, but I was pondering over a problem, a kind of a derivation, which is a covariant derivative required for. I got stuck in a problem. It was late to any of the professors. I searched through internet, but I cannot find a proper real, I would say, answer. So I need to talk some of the professors and get some lecture notes, go to colleges and universities, at least get a kind of a primary source for handling these people. Believe me, I was stuck and I was unable to find out. Vis-a-vis, when I am stuck with making any kind of a prediction or deducing anything related to quantum mechanics, operators, eigenvalues, there is a huge amount of resource as itself available in internet. You can find a lot of professors, teachers, WhatsApp group where quantum mechanics are talked and dealt with. I am not saying my personal favorite subject is general relativity. I am not saying that general relativity is actually cannot be found, but comparatively, if I compare with GR and QM resources are more. So the availability of resources, in case that you really get stuck into certain things, the availability of resources in quantum mechanics is much more compared to that of general relativity. And finally, the practical applications of quantum mechanics is much, much more compared to that of general relativity. Okay, so what I am trying to tell out of this entire video, and it is a time that I should draw a conclusion, a kind of an unbiased conclusion. So first thing is that GR would require, to be very honest with you, I have been into GR for quite some years. I can tell you with my honest opinion, you need to have an intuitive mind. You need to have that kind of a mindset which can think intuitively. Don't take me wrong, I'm not undermining you that you cannot do it. Very well you can do it, and this is the reason I'm making this video. In order to motivate you that you can take any one of these subjects. But I'm just telling you on an unbiased way what are the pros and the cons. So first thing is that you need to have an intuitive mind, a strong visualization power if you want to go and take up general relativity seriously. Number two is that you need to have a very good understanding of classical mechanics, especially learn the classical gravity very well. Third thing is that the availability of resources compared to quantum mechanics is much less. And in terms of career opportunities also, general relativity has got less amount of practical application considering the that of quantum mechanics. Now coming to quantum mechanics, if you are mathematically inclined, if you are very good in quantum mechanics, this is the best subject for you. Number one. Number two is that you don't have to have a very good idea of abstractness or intuitiveness. Mathematics will solve out the problem. You don't need to have an idea of something as huge as differential geometry, without which you cannot understand quantum mechanics. The number of resources are widely available in quantum mechanics, and the career opportunities as far as India is concerned, India, Thailand, Vietnam, I'm talking of the Southeast Asian countries, quantum mechanics has got a huge amount of resources. And also quantum mechanics is showing to be a promising future with quantum computing coming up, with Google launching Sycamore and other things coming up. Quantum mechanics and the principles of quantum mechanics used in cyber security and other ways seems to be a very promising future. So that's all for today's video. I hope I can give you a very unbiased idea about general relativity and quantum mechanics. Again, it's a kind request to those who are watching this video. Don't take me wrong that I am biased, or I'm not saying I have made more videos on GR rather than QM. But this is a very practical idea that which one you should take. Think yourself, consult with your parents, talk to your tutor. You can even talk to me if you want. Think that what are the positive things that you you can do mathematics well. Based on that, based on the career opportunities, based on the resources, go for the career, go for taking up the subject as a specialization. That's it for today's video. I hope I can give you an idea. Please do subscribe to my channel Physics for Students and click on the bell icon to get all the notification from Physics for Students. I'm thankful for you for watching this video. I will wait for your comments. What do you think and what is your way of taking up either general relativity or quantum mechanics? I will be back soon with more videos. Till then, have a good day and may the good Lord be with you.